Yo, what's going on, guys? Welcome back to day 8 of the Cyber Advent Challenge. So, this one is actually pretty cool because this is something that you guys hear about all the time. I think they did a really good job of kind of implementing this, even though it kind of doesn't follow the story, but I like it. I think they did a good job. So, before we hop into it, make sure you guys like the video, make sure you guys subscribe. We're past 2K, that's huge. Our next goal is obviously 3K, but next year, our goal is 10K. I know that's a huge goal, but this year we reached the 2K. I want to get all the way up to 10. So let's keep growing. Let's keep getting bigger. And let's keep working together as a community. Join the Discord. The Discord is always there to help people. If you join, just know we don't do illegal stuff in there. So if you try and ask, you're going to get blocked. Just know that. All right. None of this is illegal. All right. So we're on day 8. So check out the water. Okay. So apparently there's another walkthrough. I know there's other walkthroughs. I do it a little differently. I don't just give you the answers. I don't just walk you through it. I explain things. So my videos are longer. So if you're not prepared for that, you may want to check out the other videos, but that's how I do things. Okay. So learning objectives. We're going to learn what smart contracts are, which I believe smart contracts were just in the news the other day. How contracts are related. Understand, exploit, common smart. Okay. So first things first, what's a blockchain? So you guys hear about this all the time. You guys hear about the blockchain. You hear about, cryptocurrency and NFTs and all this stuff. They're all on blockchains. Okay. Easiest way to think of a blockchain, right, is you have 10 of your buddies. Okay. You have 10 of your buddies. You guys all own, make your own currency, whatever. Well, every time you buy or trade something with your buddies, you guys all have to witness it. You can only buy or trade together, right? That's what a blockchain is. So what happens is, in a blockchain, you buy something, whether it's an NFT, cryptocurrency, whatever, it doesn't matter what it is. Everybody that's a part of that blockchain, and so anybody that has the same cryptocurrency, that type of stuff, they all witness it. And when they witness it, they write it down. So, for instance, your computer's running a blockchain, your computer's part of a blockchain. So your computer says, hey, I just witnessed somebody made a trade to so-and-so over there. I write it down. I jot it down. So now when someone says, hey, how much money do I have in my crypto wallet? The blockchain can say, well, 500 people saw these transactions, which verify that you have 10 Bitcoin in there, right? So that's how it works. Everybody witnesses it. That's why it's a chain. Everybody witnesses it, and everybody agrees to it, right? If everybody doesn't witness it, or if for some reason there's some sort of mistransaction where something happened and nobody witnessed it, and the computer wasn't online, whatever, it's not going to go through. It has to be on that blockchain. It has to be witnessed, okay? Now, a lot of people have confusion here because a lot of people say, well, if that's the case, then anonymity doesn't exist, right? Because everyone's heard that criminals use cryptocurrency, right? Very common. A lot of people say, well, okay, well, how can they use it? Because then everybody's witnessing them using it, and then now they're in trouble. No, the reason is you don't have to have a physical, or you don't have to put your name to a crypto wallet. You can keep them on a flash drive. You can keep them on your computer. You can keep them wherever. All it is a key that you have, a physical key, whether it's an actual typed out key, whatever. It's a passphrase, basically, or a key to get into the crypto wallet. So if you never use your name, never sign up, never log in with a IP from somewhere you live, that type of thing, if you never actually assign yourself to that, you are now anonymous. So now when you get money into there, guess what? It can be tracked to the bank account, but you can keep moving it. You can go to different cryptos. You can go put it in a bank account in a different country. There's all kinds of ways to get this money out of there. And that's why cryptocurrency is also used for money laundering. So keep this stuff in mind when you guys are, if you guys dabble in crypto, just not that it's dangerous by any means, but that's why it's so volatile. That's why it goes up and down, is because it's not just used for legal purposes. And because of that, it adds a lot of volatility to the market. Okay, so that was a long rant, but that is important to understand the blockchain, that it's just one big group of people witnessing transactions. That's all it is. Okay, so now introduction to smart contracts. So what's a smart contract? It's a program. Simple. simple. They try to make it sound smarter than it is, in my opinion, but it's a program. So it's something that people design. So you can see, building a smart contract may seem intimidating at first, right? So you can read here, a majority of practical applications of blockchain rely on technology known as smart contract. Smart contracts are known as the backbone of decentralized finance applications. So decentralized means it's not controlled from one server. It's not centralized. So everybody has control because everybody witnesses the transactions. So that's decentralized, okay? So decentralized finance applications facilitate currency exchange. So what does that mean? A decentralized application is basically a finance application, is an application sitting here that says, hey, when someone when someone buys cryptocurrency from you, when you get the money, the cryptocurrency comes. A program does that, right? Like, you're not physically going and getting a Bitcoin. That's not a thing. It's not. So a transaction happens with an application. That is what a smart contract does, is it does that transaction. Now, here's where it gets interesting. You can take advantage of improperly written smart contracts. It's the same as, they make it seem very complicated, but it's not. It's the same as when someone writes a program and they don't do some sort of validation. You can take advantage of that, right? You can change it. You can do that. So what they're showing here is contract A authorizes, so you can see here, contract A, this is all it is. It says total balance is 200 Ethereum. Contract B balance is 1 Ethereum. So here's contract B. They're going to deposit 1 Ethereum in there. That's the contract. That's it. Just deposit it in there. Now, here's the second one they're showing. Now, if the conditions are met, then it will do it. So you can see conditions, balance is not empty. So if there's money in here, which there is, you can withdraw 1. So same here. It send Ethereum to contract B. Contract B balance is 0 Ethereum. So contract B's balance is 0, but since this is not empty, they deposit 1. Okay. Let's see. So then we got condition, balance is not empty, blah, blah. So here's where they're trying to show basically that you can make other calls before. So what it is they're withdrawing the Ethereum and then they're depositing the, whatever they're trading. So the problem with that is, if you put calls in between, guess what? It doesn't complete, right? It's going to do the other calls first. So what that means is, I'm going to withdraw an Ethereum, but I'm not telling it to finish. I'm not telling it to give you mine now. I'm telling it to do something else. So what ends up happening, the reentrancy attack, as you'll see here, is I'm going to withdraw my Ethereum. So I make a transaction with you. We have an understanding. I'm going to trade you 1 Bitcoin for 1 Ethereum, whatever. It doesn't matter. But what I'm going to do is, before I deposit my Bitcoin to you, right after I take my Ethereum and right before I deposit my Bitcoin to you, I'm going to put a other function in there, or as they call them, a class. What I'm going to do is I'm going to put it in there to make an infinite loop. And what that means is, it's going to basically say, go to the top, go to the top. So what it's going to do is, it's going to keep withdrawing, but it's never completing that actual deposit, if that makes sense. So you can see here, this withdrawal function requires that the balance is greater than 0, obviously, because you can't withdraw from 0. Send the account balance to the contract that requests a withdrawal. So he's requesting a withdrawal. So these are the steps that they do them in. They require the balance is greater than 0. Check. Send the account balance to the contract that requested the withdrawal. So send whatever they need to the withdrawal. Then set the account balance to 0. So that's what we're going to do. So now requires value greater than or equal to 1, which makes sense because I can't ask for something that's 0. Deposit 1, okay, and then withdraw all Ethereum from the account. So he goes ahead, does that, right? That'll work. Okay, cool. But you can see here, if you go down here, and it's hard to see these lines here. I know you guys can't see that well, but there's lines here that show the order in which they go. So now, require value greater than 0, deposit 1 Ethereum, boom, boom, okay. Now you can see that the last thing that it does is change this balance to 0. That's the last thing that it does. Okay. So what we can do, if you go down here to the infinite loop that they're showing, is require value greater than or equal to 1, deposit 1 Ethereum, which same thing, and then withdraw, right? But then you can see the fallback action. So what happens is, and you can see they explain it right here. The fallback function calls the withdrawal function again. So if you're not familiar with programming, this might be a little bit confusing to you, but just know this is what it's doing. So since it was never fully resolved, meaning it never completed, the transaction never completed fully because you stopped it in between, right? It's going to do what's called a fallback function. So, hey, this didn't complete. We need to fall back and make sure that things are good. But the difference is they wrote the fallback function to withdraw everything, to just take everything. Well, why is that okay, right? It's not okay, but what's happening is this is getting interrupted, and the programmer purposely wrote it, the attack function here, to fall back to withdraw everything. And so this is before it gets to the set account balance to 0, it's withdrawing everything. And it's just going to keep running an infinite loop, meaning you're just going to keep taking everything until there's 0 balance, because then there's nothing to take, right? So this is basically, it's an exploit where, hey, we're going to make a transaction. Me and you are going to trade, right? And I say, here's $1, and you're going to give me 1, yen. So we're trading currency. So here's $1, but then you have 200 yen in your hand, right? And you're just handing me one at a time. But every time I give you that $1, and then I take the yen, but then I tell you, hey, I gave you $1, you never gave me yen, right? And you keep going, well, you're a person, not a program, but a program doesn't think. So a program's like, oh, I didn't give it to you, here you go, and just keeps giving you all of them because that's its fallback, because that's what you're telling it needs to happen. So it's just a way of interrupting that transaction and taking the rest of it. Now, this sounds kind of silly, right? Because it sounds like this would be easy to catch, but it's not, and it does happen. So for this task, we're going to use Remix IDE. So if you guys aren't familiar with IDE programs, it's just a way to look at, okay, cool, it actually uploaded them or kept them uploaded for me. That's awesome. Okay, so what we're going to do is we're going to go ahead and use this Remix IDE. And then so download these 2 files, which were at the beginning of the thing. I already downloaded them, and they actually already are uploaded here for you, but I'll show you how to upload them because I didn't expect it to save. So now we'll go here. So first thing you gotta do is go to the Solidity compiler. My goodness, I can't talk. So first thing you want to do though is you want to basically upload them. So you go over here to File Explorer, and then you would say, well, if it opens, there you go. Then you'd say right here, load a local file. So take the 2 files they give you on this and upload them. They're right here, attack and Ethereum store. So now we're going to go to the Solidity compiler, if I could talk. And then we're going to go here, and they ask you to go to the 810 because that's what the compiler needed. Okay. So there's the 810. Perfect. Now what you're going to do is you're going to go over here, go to the attack. Then I open both just to save time. Then I go to the compiler. You can do either one. You need to compile them both because this is just written in plain code. You need to compile them. This is a compiled language. So we compiled them. Don't worry about these errors because it's not a big deal. Now, we compiled them. Okay, don't worry about the errors. Okay, so now that we compiled them, we need to deploy them and interact with them. So when we deploy them, so the store sets up the store, right? So we go to the Ether store, and we want to say, go over here to deploy and run. So the Ether store, so this one, we need to make sure we're on the right thing. Okay, perfect. We're on the right account. We don't have to put a value in there yet, but we want to change this to Ethereum. Now we'll go ahead and deploy this because we want to deploy the store. And you see it's loading. Boop, 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 boop. And let's see if it's finished. Okay, so there you see it says 0. All right, perfect. Okay, so now if we add, let's see, I don't know if that's the right one. All right, that's not the right contract. That's why, because the contract is there. I need store. So make sure you change the store. That's the one. Now we got it loaded. Now we go here. So now we have an actual store. This is an Ethereum store built. So now let's say we want to change this to, we'll just say 100. Doesn't matter what you change it to, and then deposit. Now you see the transactions happening here. This is how it works. The transactions happen here, and they're being recorded. Now, I'm the only one on this store, so I'm the only one recording it. But now you see up here, when you go to where is it? So now you see balance. All right, did we actually get it to deposit? Let's see. Oh, it says pending. Okay. So now you can see transactions recorded. So this is where, like on an actual blockchain, you would see a bunch of transactions. That's why. Okay, so let's see what they want us to do. Okay, so we've deployed the store. We can now interact with the contract directly underneath. Okay, so we can actually interact with the contract. So we've got the store. We've deployed it. Blah blah blah. Let's make sure that we have everything right before we get crazy. Okay, so note when pressing the deposit button, this is a public function we're calling just okay. So we can now interact with the contract underneath the deployed contract subsection. To test the contract, we can deposit Ether into the contract to be added. Insert the value into total box and value 4 and select the currency and drop down. Okay, so now the currency, we got Ethereum, but the problem is we're not getting the Ethereum deposited there. So let's try. Maybe you can only do a few or something. Yep. So you can't do 100, but you could do 10. So we've got 10. There's 10 Ethereum. Okay. So we've got 10 Ethereum in our balance. Now what we want to do is we want to take advantage of the attack one. And the attack one's going to do exactly what we just covered. So now we go over here and we take the attack one. And we're going to go run that on here. So what we're going to do is we're actually going to change this once we get over here. Attack. So now we're taking the attack. Now watch what happens. So we're going to go ahead and deploy this, but keep in mind you have to have something, because if you remember, it checks if the balance is 0 or it's got to be at least 1. So we'll take 1. So keep in mind this function theoretically is supposed to just withdraw 1 Ethereum, but it causes that infinite loop and then it asks for everything. So I go ahead and add it. Boom. Now you'll notice it's running. Actually, it gave me an error, so let's see. Let's go ahead and compile it again just to make sure. Oh, it says invalid address. So what I had to do is you have to copy this address. I forgot. Copy this address and give it, because you have to give it an actual target, right? So we copied it, we paste it. So now we go ahead and deploy it. What happened now? Oh, there's 0 value. Okay. This transaction has been reverted to its initial state, blah, blah, blah. So why is it not working now? Let's go back and compile it. For some reason, it's not compiling. It's just sitting there. All right. There we go. It actually did something there. All right. So it tells you on there not to worry about the errors. So let's see. So there we put our value. We put our location. Let's deploy it now. Let's see what's going on. Okay, that's our correct account. All right. Deploy the contract. Need to provide reference to the contract you're targeting. Yep. Confirm the contract was deployed. Okay, so clearly we missed something, or I messed something up here. Okay, so we've got the attack. That's the correct target. We've got the target here. Oh, that's why, I think. Do we have to add the actual address of the attack? Let's see. Copy the address from ETH store label 11, which we did, and paste in the value text box under 8, which we did. Okay. Confirm the contract was deployed. All right. So we have you can see we have that. That's correct. So that's where we're at. We've now successfully see balance update. Now that we've deployed, switch to a different account. Drop down label 2 and select new account. Okay, so we got to select a new account. That's why. And the reason we have to select a new account makes total sense is because we're trying to take from ourselves, right? I don't even think that's possible. So we've got a new account. There we go. Attack 1. So you can see 10. Now this one, it looks like they already have 100 Ethereum, so let's keep that in mind. And of course that didn't work either. Okay. So we've got a new account. Drop down level 2, add new account. So I'm not going to add a new one. I'm just going to. Okay, this time you'll be exploiting the original contract and should see the exploit actively occur. Yes, correct. So I'm not sure why this isn't loading correctly. We have the store, we have the attack. I don't know if this is not getting compiled correctly. Let's go ahead and try the compiler. If I have to upload it again, I will, but... Okay. Because it's not actually showing it working. But they say in there not to worry about the errors. But I don't know if that's actually right. Okay, let's go back to this one and then run the attack. Well, we can't. We got to go to this one. Okay, attack. The address we've got, unless maybe I'm messing up the address. Okay. All right. Now you have to have at least one value. And let's do it. Nothing. All right, we're going to figure this out here. All right, let's go back. I'm wondering if it matters that I did this before. Okay, 810 commit. Maybe I got the wrong compiler. 810 commit. 810 commit FC. 810 commit FC. Nope, that's the right compiler. All right, so let's just redo the whole thing. You ready? So we're just going to redo it. And, all right, so go ahead and go to the compiler. We'll get rid of that. Trash all of it. All right, compiler. We'll go ahead and go to attack and this. And we'll go ahead and compile it. Right, whether or not that worked, I don't know, but it should have. So you see they say right here not to worry about the, I didn't write this code, obviously. So they say not to worry about the errors. That's fine. I wonder if it's just because I've already done this, because it ran perfectly fine the first time. But we'll go ahead and try this again. So we've got this account right here. Doesn't really matter what account you use. We'll just do this account. It's got 100. All right, so we'll do the Ether store, Ethereum store. Okay, and then we'll deploy that. That should make the Ethereum store. There it is. We'll deposit 10 in there. Not deploy, deposit. Okay, so there we see it updated 10 Ethereum. Okay, now we should go to attack, change the account because we want to get it from that account. There's the address we want. I want to change this to the attack. And we just need one. We just want to take one. We don't want to take that many. And let's go ahead and wait a minute. Maybe I had the address in the wrong spot the whole time. Can you imagine? Let's see. Okay, so yeah, I had the address in the wrong spot the whole time, I guess, because you saw that now we have this. Okay. So I think you actually deploy the attack first. I think that's what I was doing wrong. If you guys notice, because I wasn't reading it, I was just doing it. You deploy it, and then that creates this, and then you put the location, and then you attack. So now we need to put this at 1. That's what I was doing wrong. I was putting the address store here, and that address store already exists. So here we go. We'll go ahead and attack. Remember, you have to change that to 1 or you'll get an error because it's going to check first thing if there's any balance. So we'll go ahead and attack. And then you'll notice there's 0 now and 11 here because I had 1. And then this had 10, and we took all of theirs. And then you see flag 411 your something 15 mine. All right. So you can see there's the flag. I know that was a pain in the butt, but I want you guys to see those errors because you might run into them. And the first time I did it, it ran fine, but I also followed these directions. The second time I did it, I wasn't following the directions because I was trying to make the video and just do it. And that's what happens. But I want you guys to see that stuff because that's how you learn. And that's how you figure out how this stuff works, because I made the error and I realized quickly that something's wrong with the address because it was trying to call to the same store, and I needed to create this one over here, the attack one, and it was not creating that. So make sure what you do is you deploy the contract first and then add the address and attack. That's what you need to do. So hopefully this helps you guys. Hopefully you guys understand. You can see if you go down here, this you don't need an answer. This you don't need an answer. And there is the flag. And there you go. That is day 8, guys. And hopefully day 9 comes out soon, and I'll get that up to you guys. Thanks.